Good evening, class. This is Mrs. Albright, and tonight we are working on Module 3, Lesson 35, and our objective is to multiply a multiple of 10 by a two-digit number using an area model. So we're doing the same types of problems as we did yesterday, but practicing with an area model, which will really help us as we get into larger, more complex multiplication problems. So make sure you have your scratch paper and a piece or a whiteboard, and so that you can work along with me. And let's get started. Our first problem is 30 times 25. So we are going to solve this using an area model. So we know, as a reminder, area is equal to length times width. So our area model is going to be a big rectangle. And here, if this were 3 times 25, we could do an area model 3 times 20. And then this would be 5, and we could solve this. 3 times 5 would be 15. 3 times 20 is 60, and then we could add those up to get the answer. But this is 30 times 25, so our area model is bigger. I'm still going to take the 25 and decompose this along the top. 2 10s, 5 1s. And I'm going to put the 30 on the side. So the equation for this section of the area model is length times width, 30 times 20. We can think of that as 3 10s times 2 10s, and that is equal to 6 hundredths. Or we can write that as 6 hundredths. The area model for this box, when we are looking at the length times the width, would be 30 times 5. So 3 10s times 5 1s is 15 10s, or we can also write that as 150. When we add these two amounts together, 600 plus 150, we end up with 750, and that is the answer to our problem, 30 times 25. And we use the area model to help us get partial products, or part of the final product. We are going to do another example for 60 times 34. So I'm going to draw my large area model, and I'm going to put 60 on the side, or 6 10s, and then I'm going to decompose the second factor, 34, as to 3 10s, 4 1s. And when I multiply this, 60 times 30, that would be 18 hundredths, or I could rewrite it as 1,800. And then 60 times 4 for this section of the area model would be 24 10s, or 240. Now, if I were to rewrite this problem vertically, and learning how to do these area models and practicing with these partial products will really help you when we get to problems where this is not a multiple of 10. Let's say this was 63. So please really practice these steps and make sure you're asking questions if it's not making sense. But when I recorded the first part, I'm doing my 60 times 4. And that's what I did right here, the 60 times 4. The product for that was 240. Then I'm going to multiply the next part, the 60 times the 3 10s, and the product for that was 1,800. And then when I add those two products together, I get 2,040. Now, eventually we want to get away from using those area models. Those are kind of like training wheels on a bike. So this is kind of what you want to be thinking about in your mind as you're multiplying these large numbers like 34 times 90. You want to think of it in terms of those two partial products, the 90 times 4 1s and the 90 times the 3 10s, and come up with those two partial products and add them together. So if this, I'm going to picture that area model in my mind with my 3 10s, 4 1s along the top, my 90 on the other side, and then I'm going to ask myself, The 3/10 times 90, what is that partial product? And the 9/10 times 4, what is that partial product? So what is the partial product when I multiply 4 times 90? And what is the partial product when I multiply 3/10 times 90? And then finally, what is my final answer? Hopefully you got that 4 times 90 is 360. 30 times 90 was 2,700. And when we add these all up, we end up with 3,060 as our final answer. Here are your final quiz questions. Make sure you do the best that you can. Work these out on scratch paper on your whiteboard. Practice drawing those area models and recording what your partial products are. And bring back any questions you have to class tomorrow. Have a great night.